Hello everyone, thank you for allowing me to join you virtually. Today I'll be presenting evidence that etiological animal tales are a statistical universal in forager societies and offering an explanation for their pervasiveness. Before doing that, however, I need to explain my terms. In this talk, the terms hunter-gatherer and forager refer to peoples who depend on wild resources for a substantial portion of their subsistence. This study thus includes some peoples who made their living in part through horticulture or pastoralism. By etiological animal tales, I mean stories that explain the origin of an animal or one or more of its characteristics. By characteristics, I mean not only markings or morphological features, but other qualities such as behavior, life history, habitat, diet, and sign. The main research question addressed in this study is why etiological animal tales are so widespread across forager societies. I hypothesize that these stories are an important means of storing, refreshing, retrieving, and transmitting traditional zoological knowledge. If this hypothesis is true, two predictions follow. First, we would expect these stories to feature animals that are important resources, hazards, food competitors, or ecological cues in the local habitat. Second, we would expect these stories to contain information that is useful for identifying, predicting the availability of, locating, stalking, capturing, killing, processing, or avoiding injury by local animals, or for using them as ecological cues. The prediction that etiological animal tales transmit zoological knowledge begs the question, why is zoological knowledge important in forager societies? The answer lies in the benefits and risks associated with animals. On the benefit side, animals are important sources of food, hides, sinew, and other raw materials for making implements. Animals are also used as cues of the arrival or presence of other animal species, the ripening of plant resources, or imminent changes in the weather. On the risk side, animals pose a range of threats. Dangerous encounters with animals can occur in the context of the hunting of humans by predators, interactions between humans and their prey while hunting, competition between humans and predators over kills, and interactions with poisonous, stinging, or biting animals in the course of everyday activities. Zoological knowledge is critical to dealing with all of these problems, the most obvious of which is hunting success. As you can see in the slide, there is widespread agreement among anthropologists that the most difficult aspect of hunting is not hitting the target, but locating game and getting close enough to kill it. Gervin and his colleagues provide quantitative evidence in support of these ethnographic observations. In a study of Chimani men's hunting proficiency, they found that caloric return rates don't peak until middle age. This is because successful hunting also requires good decision-making skills. Given various options, a hunter must decide which species he's most likely to catch given current conditions, and which species will provide the biggest caloric payoff relative to the amount of energy required to catch it. This requires extensive ecological knowledge. Gervin et al. Found that indirect animal encounters, that is, encountering animal sign but not the animal itself, peak in the mid-20s, and direct animal encounters, where an animal is located but not killed, peak at around age 35. However, kill rates don't peak until age 39 or so, and caloric return rates don't peak until the mid-40s. They conclude that, among Chimani men, marksmanship is not the critical issue in determining age-related changes in hunting return rates. Rather, it's the ability to find an animal and get in a position to get a good shot at it before it escapes. The finding that kill rates and caloric return rates don't peak until middle age suggests that animal knowledge is acquired in considerable part through direct experience. However, both the rate and quantity of knowledge acquisition can be greatly increased through social learning, which reduces time and energy costs as well as risk exposure. Thus, social learning offers multiple fitness advantages, and ethnographic evidence indicates that foragers do indeed share zoological knowledge. For example, Blurton, Jones, and Connor report that Kung men acquire considerable animal knowledge from telling the hunt, that is, from telling the story of their day's hunting excursion or past hunting excursions. Similarly, a Gwich'in informant reports that many of the stories she heard growing up were about animals, and that, by telling the stories, the elders and our parents were able to pass on their knowledge and the knowledge of our ancestors. The stories were interesting, as we learned how to hunt the animals, what time of year, the best locations, and the best ways to hunt. It's plausible, then, that etiological animal tales are used to transmit zoological knowledge. In the course of explaining the origin of animal traits, these stories can provide information about habitat, diet, and behavior, among other things. A dentist story about a woman who married a caribou illustrates this principle. The story reports that the caribou ran away as far as the river. The caribou man heard his wife talking, so he went back up a little ways. Even now, when you chase a caribou, he beats it, but then he stops and starts to come back again a little, to find out what's the matter. This little piece of information about caribou curiosity may seem insignificant, but it's very useful for a person who has to hunt these animals for a living. The story of the caribou man also illustrates how a story that is fictional can nevertheless transmit factual information. The key is to separate description from explanation. As Barber and Barber argue, a story's observations about the world can be true, even if its explanation for them is not. Thus, a story may offer a supernatural explanation for how an animal acquired a certain trait, but its description of that trait may be 100% accurate. This is illustrated in a story from the Carracks of Siberia. The story explains that long ago the fox was envious of the wolf's bushy tail. So she tied bones to the wolf's tail while it was sleeping, then woke it up and shouted that the ones with the big tusks were after it. The wolf jumped up and ran into the woods, and the bones got entangled in a bush, tearing off its tail. The fox then took the tail home and sewed it onto her daughter's tails, and that's how foxes got bushy tails. This part of the story is the explanation, and from a scientific perspective is fictional. However, the story then tells us that now the wolf has a flat, thin tail and the fox a fluffy one. The end of the fox's tail is white, but that of the Arctic fox is black. This part of the story is true and provides information that's useful for distinguishing between two different fox species and between foxes and wolves. As illustrated in the slide, even when animals are similar in size, shape, or color, their tails are distinctive. Information about animal tails is especially useful for identifying species from a distance, when they're moving very rapidly, or when they're visible for only a split second. Given that etiological animal tales are common in forager oral tradition, and given that they identify animal traits, I wanted to know whether they were universal, and whether, cross-culturally, they encode practical zoological information. To do this, I generated a list of forager societies using Murdoch's ethnographic atlas. I operationalized forager as a combined score of 7 or more for dependence on gathering, hunting, and/or fishing. Murdoch uses a 10-point scale, so a score of 7 is 70%. This search yielded 237 forager cultures distributed across 102 culture regions in 5 of the atlas's 6 geographic areas. Because some culture regions contain more than one forager culture, and I wanted to balance the sample, I only analyzed stories from one culture group per culture region. To generate the study sample, I conducted a library search for story collections for each culture region, beginning with the first culture in the region and continuing until a serviceable collection was found or all forager cultures in the region were searched. By serviceable, I mean collections that contained a representative sample of traditional stories and were told by indigenous informants to social science professionals. I found suitable collections for 65 of the 102 culture regions. Because some collections contained only one etiological animal tale, I selected only one story per collection for analysis, again to balance the sample. Thus, the study sample consisted of 65 stories. For collections that contained more than one etiological animal tale, I chose the first story I encountered that was complete and sufficiently rich in detail. This was a subjective but necessary assessment, due to cultural erosion and variation in informant story knowledge. Some informants are well versed in their oral traditions, while others are only capable of generating a bare-bones plot summary. And for the purposes of this study, it was important to use stories that were most representative of past storytelling practices. As you can see in the slide, the study sample is biased toward North American cultures. This is due to the low availability of folklore collections for hunter-gatherer cultures on other continents, and also to my being limited to using collections in English. However, the cultures represented in the sample occupy a wide range of habitats, including coastal, desert, savanna, woodland, mountain, taiga, and tundra environments. The sample also includes a wide range of latitudes and climates. Thus, the sample enables the hypothesis to be tested across a wide range of ecological and cultural conditions. Once the sample was assembled, I analyzed each of the 65 stories for 9 different content themes. Each theme encapsulates a different type of zoological information. Availability includes information about the quantity or season in which a resource is available. Behavior includes anything that the animal does, and diet includes anything that the animal eats. Extraction includes hunting, trapping, fishing, or other capture techniques. Information about processing, for example, how to butcher an animal properly or how to tan hides. And information about which parts of the animal to use for what purpose. Habitat includes information about where the animal can be found, and hazards includes any information about the way or ways in which the animal is harmful to humans. Interspecies relationships refers to the use of animals as ecological cues, to locate or predict the availability of other animal or plant resources, to predict weather or seasonal change, or to avoid predation. For example, the arrival of waterfowl in the spring may signal the ripening of certain plant foods. Similarly, predator-prey relationships can be used to locate game or avoid predation. For example, wolf tracks might lead you to a moose or caribou, and fleeing springboks may signal the presence of a lion. Sign includes marks made by an animal on the landscape, or information about how to locate, use, or interpret those marks. And finally, traits includes morphology, markings, capacities, such as a keen sense of smell or hearing, and life history traits, such as when or how often the animal reproduces, or litter size. Here you see the results of my content analysis. All 65 collections contained at least one etiological animal tale, lending support to the hypothesis that these stories are a statistical universal in forager oral tradition. The table you see here shows how frequently the 9 different types of zoological information occurred in the study sample. As you can see, information about behavior, habitat, and traits was most common. 60 of the 65 stories contained information about behavior, 51 contained information about habitat, and 48 contained information about traits. It's important to note here that I analyzed the stories for the presence of each type of zoological information, not the quantity. For example, if the story contained multiple pieces of information about an animal's traits, such as its color, size, and temperament, I didn't factor all of those pieces of information into my analysis. I'm hoping to do this in a future study, but the takeaway message here is that the present study underestimates the amount of zoological information encoded in the stories. The table you see here shows how many different types of zoological information tend to be encoded in a given story. As you can see, the majority of the stories, 75%, encode 3 to 5 different types of zoological information. 18 of the stories in the sample contain 3 different types of zoological information, 13 contain 4 types, and 18 contain 5 types. So what this initial analysis shows is that etiological animal tales occur predictably across forager societies, and that cross-culturally they consistently encode zoological information. However, since I only analyzed one story per culture, we don't know whether etiological animal tales in general are used to encode zoological knowledge. That is, we don't know how widespread this phenomenon is across the genre itself. To investigate this, I analyzed complete sets of etiological animal tales from 10 different forager societies on 5 different continents. To generate the study sample for the genre analysis, I used story collections that contained at least 3 etiological animal tales. From these, I chose 2 cultures each, from Africa, East Eurasia, the Insular Pacific, North America, and South America. I chose 2 cultures from each continent because I could only find suitable story collections, that is, collections with 3 or more etiological animal tales, for 2 African forager cultures, and I wanted to balance the sample geographically. To the extent that it was possible, I also balanced the sample ecologically by using cultures from diverse habitats, as shown in the photos. Thus, the study sample encompassed 2 cultures from each geographic area for a total of 10 cultures, and used 1 story collection from each culture. The number of etiological animal tales in each collection ranged from 3 to 23, as shown in parentheses next to the name of each culture. Since I wanted to see how pervasive zoological information was across etiological animal tales, I didn't balance the sample numerically. I ended up with a total of 99 stories in the study sample. I analyzed each of the stories for the same set of content themes used for the previous analysis. The results in this table are shown as percentages. As you can see, the results for the 10 culture study are very similar to the results for the 65 culture study. Each of the content themes was referenced in at least some of the stories, with behavior, habitat, and traits once again being the most common. In the 10 culture sample, 84% of the stories encoded information about animal behavior, 73% encoded information about habitat, and 87% encoded information about traits. This table compares the number of content themes referenced per story in the 2 study samples, with the results shown as percentages. Once again, the results are very similar for the 10 culture and the 65 culture studies. All of the stories in the 10 culture sample referenced at least one content theme, and the majority, 68%, referenced 3, 4, or 5 themes. In other words, in both study samples, the majority of stories encoded 3 to 5 different types of zoological information. Thus, the pattern of etiological animal tales encoding zoological knowledge appears to hold across the genre. In the time remaining, I'd like to show you a few story passages to illustrate the different types of zoological information and how they're encoded in forage or oral tradition. Before I do that, however, I need to say a few words about the use of anthropomorphism in these stories, which is key to decoding the practical information they contain. The anthropomorphic characters in these stories don't make a lot of sense unless you understand the distinction that many forager cultures make between events that occurred in the recent past and events that occurred in the deep past. During the latter period, the world was different than it is today, and things happened that are no longer possible. Then a period of great change occurred during which the world was transformed into its present state. One way in which the deep past differed from the recent past is that the animals were people. They talked, hunted, gathered, made tools, got married, and engaged in trade, warfare, and celebrations just like humans do. But they also exhibited animal traits. For this reason, the deep past is typically referred to as the time when the animals were people. During the period of transformation, the animal people lost their human qualities and acquired the form in which we know them today. Etiological animal tales are set during this period of transformation, and thus explain how animals acquired the traits they exhibit today. The story you see here is a case in point. It's about a man named Blanket Lizard who is both a man and a lizard. This story is from Australia, where a number of different lizard species are eaten. Obviously, before you can eat a lizard, you have to catch one, and this story provides information that is useful for this purpose. First, it tells us what color the lizard is, which is useful for detecting and identifying it. This is seen when we're told that Blanket Lizard painted himself all over with red ochre. The story also describes the lizard's preferred habitat, the soft sand along the creeks. The story reiterates this point by telling us where the lizard is unlikely to be found. Blanket Lizard didn't like the hard ground because it hurt his feet. Once he missed his way and found himself in sharp, rocky country. "I've come to the wrong place," he said, looking about and seeing rocks everywhere. "I'd better go back and find the right track." The message is clear. If you're hunting blanket lizards, the right place to look is in soft, sandy ground near creeks, and the wrong place to look is in areas of hard and rocky ground. Additional habitat information is seen when the story tells us that he found a good cave to live in. The word cave is probably being used metaphorically here. Given that the lizard lives near water, it probably refers to holes in creek banks rather than actual caves. Finally, the story provides information about behavior, noting that every day he went hunting and every night he came back to the same place to sleep. Here we learn that this species is diurnal and has a permanent residence, which is useful for locating and intercepting it. The passage you see here is from a northern Paiute story in which gray crane, that is sandhill crane, kills bear for having an affair with his wife. This story illustrates a common feature of etiological animal tales. Because the characters are anthropomorphic, these stories often transmit social information, such as information about behavioral norms, in addition to zoological knowledge. Unfortunately, due to time constraints, discussion of the former will have to wait for another day. Here I'll focus on the animal information encoded in the passage. At this point in the story, Crane has killed Bear, but he's still angry. So he goes to the meadow and sings a song in which he challenges all of the bears to a fight, and digs in the meadow with his bill to demonstrate how he will kill them. Since cranes root around in the ground for tubers, insects, reptiles, and amphibians, this is clearly a reference to crane feeding behavior. However, it also encodes information about a hazardous trait associated with this species. Crane beaks are powerful enough to pierce the skull of a small carnivore and the flesh of larger animals, such as bears. In fact, their beaks are so strong and sharp that they were used as arrow points by the Koyukon people. The story also provides information about an interspecies relationship between cranes and bears. Cranes are hunted by a wide range of predators, including foxes, coyotes, wolves, cougars, bobcats, lynx, and eagles. Smaller predators target juveniles, while larger predators will take juveniles or adults. Cranes defend themselves and their young by stabbing with their bill. Thus, the story appears to encode the information that bears prey on cranes, that cranes defend themselves with their beaks, and that a crane beak is capable of fatally wounding a bear. The fact that the action is set in a meadow suggests another interspecies relationship, namely that cranes and bears occupy the same habitat. If this sounds like overinterpretation to you, check out the link shown in the slide. It will take you to a video that shows a crane and a bear fighting in a meadow. The passages shown here illustrate the remaining content themes. The first passage provides information about when the animal is available, in this case, in the spring. This type of information is useful for deciding what to hunt on any given day. The second passage provides information about animal diet, which is useful for finding game. You're more likely to encounter the animal you seek if you search in areas where its food is available. The third passage provides information about animal sign. This is useful for detecting the presence of game, or, for that matter, predators, because you're more likely to see signs of an animal before you see the animal itself. The fourth passage describes a strategy that can be used for hunting emus. In so doing, it provides detailed information about how an emu behaves when under attack, and how the brothers coordinate their action to take advantage of this behavior. The story tells us that, in response to being hit in the chest by the first brother's spear throw, the emu immediately turned around and rushed at him. While the emu is preoccupied with fending off the first brother, the younger brother has an opportunity to throw a spear, which strikes the emu on the rump. The emu then turns around to fend off her second attacker, which enables the elder brother to make another spear throw, this time striking the emu in the neck. The story then tells us that the brothers keep this up until the emu dies from blood loss. In describing this technique, the story also illustrates one of the advantages of hunting with a partner. To sum up, the results of these two studies suggest that etiological animal tales are a universal genre in forager oral tradition, and that across forager societies, these stories are used to transmit zoological knowledge. It's important to note that I'm not arguing that stories are the only means of acquiring this knowledge, or that these stories only transmit zoological knowledge. As noted earlier, these stories often encode information about humans, especially about behavioral rules and norms. Other genres transmit information about other recurrent problems of forager life, such as famine, natural disasters, and warfare. Nor am I arguing that foragers consciously use stories to transmit knowledge. In many cases they do, but conscious intent is not necessary for stories to have this effect. The motivation for telling animal tales is probably what Blurton, Jones, and Connor refer to as an innate curiosity about animal behavior. They hypothesize that our ancestors evolved an interest in observing animal behavior beyond what is immediately necessary. This enabled them to store up knowledge that might be useful at some point in the future. Our species' highly developed capacities for cooperation and communication would have been sufficient to motivate individuals to share these observations with others. In the grand scheme of literary study, etiological animal tales might seem unimportant, but I see them as a tool for understanding literary prehistory, the oral art forms that preceded written poetry and prose. Forager oral tradition speaks to the impetus that drove humans to begin telling stories in the first place. As I've argued elsewhere, multiple lines of evidence suggest that storytelling emerged as an efficient and effective means of storing, refreshing, and broadcasting accumulated cultural knowledge. Humans are a species that survives by acquiring information and using it to perform complex manipulations of both the physical and the social environment. In this context, using storytelling to forewarn and forearm offspring, kin, and allies provides large benefits at very little cost. And that concludes my talk. Thank you all for your attention, and if you have any questions, I'd be happy to discuss them with you over email.